Okay, guys, this is Assad once again, and you are welcome to this session. I was actually planning on making this live, but I've been facing some network challenges, so I decided to pre-record this for you guys to come watch at any time of your choice. So in the previous video, we saw how to install Python um, on your machine, and that's your PC, whatever operating system you are using. But I'm sure most of you guys will be using Windows. And then we also looked at how to install PyCharm on your PC. Or for the Android users, we saw how to install PyDroid on your Android smartphones. So today we just continue from there, and we do that by actually looking at how you can actually program, or like how you can write Python code. Like there are two modes you can use to write Python code, like that is the interactive mode and the script mode. The interactive mode involves running your code directly on the Python shell, which can be accessed from the terminal of the operating system. So on Windows, if you want to be able to let's say let's open our command prompt in Windows, and we do that by uh, pressing the Windows key plus R. So press Windows key plus R, and in the run window you just type CMD into the box and you press enter, or you click on OK. Now when you do that, it's going to open up the command prompt for you, and then you can simply just type Python, and when you type after that, then you just press on enter, and then this will open Python in your command prompt in the interactive mode for you. So but like for Android users, for those of us who are on Android, just open up your PyDroid, open up the PyDroid application, and then when you press on the hamburger button, you see something interpreter or probably terminal. So let's go to the terminal first. Let's see what's there. So when you go to terminal, just type Python, and then you click on enter. You press on enter, and then this will also open up Python in the interactive mode for you on PyDroid. But there's a way you can also do this, and you can simply do that by going to interpreter. So when you select interpreter, this actually just opens up Python for you in the interactive mode. And then in the interactive mode, the thing about the interactive mode is once what you type when you type something, or like whatever statements you put there gets evaluated, and then like if there's any output, like the Python interpreter prints it on the screen for you, even if you without even asking for without even asking the program to print it out for you. So like say for example in a terminal, if I say maybe like 2 plus 3, I'm not asking the program. I'm not asking this piece of code here to I'm not asking the Python interpreter to print this out. But like when I press on enter, it prints out the results on the screen. This is actually one characteristic of the interactive mode. The code gets evaluated and the output gets printed out. That's if any. So maybe if I say x is equal to 5 and I press enter, there's no output associated with that. This is an expression. So like the statements get executed, and then the whatever whatever value is there gets printed on the screen for you, even without even asking for it. You can also try this if you're on PyDroid. So in the Python interpreter, just let's just type let's see 2 plus 3, right? So just 2 plus 3, and then when you press enter, you see that the value um, gets printed 5 here, even without we asking for any printing to be done. The other mode you can write Python code is in the script mode. And with the script mode, in the script mode you have to create a file, give it a name with a .py extension, then run your then run your code. So let's say uh, for the script mode, you actually save your or write your code in in a file, or like write a code and then save it in a file with the .py extension, and then when you are done doing that, you can then actually run the code. So in Python, quickly go ahead and create a file. In the previous video we looked at how to do that. So just click on the project folder here, the root folder, then you right click on it, and then you select new in the drop down menu, then in new, then you go to new file, or just pick Python file. Okay, so when you pick Python file, you can choose whatever name you want to give to your file, and then you press on enter. And then so now that we have it here, so let's do something. Let's try to do what we did earlier on. Earlier on we said 2 plus 3, right? But because we were in the interactive mode, it got printed out for us. But now we are in the script mode, so when we say 2 plus 3 and then we run this, you can, if you are running this file or this script for the first time, you can run it by saying shift plus alt plus F10. That's when you are running it for the first time, and then you choose the file, and then you just press on enter. But like if you've already run this file before, just shift plus F10 will do. So now here we can see that because we are in the interactive mode, this doesn't actually get, like, nothing is printed out. As we can see here, nothing gets printed out, because we haven't asked the Python interpreter to do anything. We haven't asked the Python interpreter to do anything. So in the interactive mode, if we actually want to see the value of 2 plus 3, what we have to say is we have to introduce the print statement. Python has an inbuilt function called the print function, and with this we can use this to print maybe like messages or whatever you want onto the screen. So you call that by saying print, then you open parentheses, open and close parentheses, then maybe whatever you want to print out. So I want to print out the value of 2 plus 3. So when I run that by pressing shift plus F10, we get a value here, which happens to be 5 under here, and then as you can see, the value is 5 here. You can also try that on your PyDroid application. Just on PyDroid, let's create a new file, and then give it the .py extension. So you can do that by clicking or pressing on the folder icon here, and then just go to select new. So okay, let's wait. Okay. So we are already in a new file. So like let's try to save this. So let's hit save. Let's select save instead. And then you see, like when we try to go to save, when we try saving it, we get maybe select folder, or maybe if you want to create a new folder. So let's just go to our internal storage, and then here let's create a new folder, and then call it, let me see, I want to call this folder, just call it whatever you want, but let's say I want to call it Python scripts. So let's just say Python scripts. Okay, so when you're done, you just press on create, and our folder gets created for us. Okay, all right. So after the folder gets created, to select this folder, you just press on select folder on top here, and then you then get to choose the name of the file. So I want to name my file hello.py. So hello.py, and then you just press on save. Now if you notice something on top here, we get the name of our file here on top here, saying hello.py, and then the path to it just right under it. And then here we can actually write some Python code. So we can say print what we did earlier on, 2 plus 3. So we want to print the value of 2 plus 3. So 2 plus 3. And then to run this code, what we need to do is we need to hit this yellow run button here, as you can see it on your screen. Just hit it, and then the value gets printed on the screen for us, 5 right here in the terminal. Okay, So that's basically like the difference between the script mode and then the interactive mode. um, we can use this print statement to print values onto the screen, whatever it is, or messages to the screen. And like for example, we can print hello world, and then when you let's actually try that out. So when you on PyCharm or PyDroid, depending on what device you are using on Py, but let me stick to PyCharm. So on PyCharm, when I say print and then I say hello world, okay, and I actually run this by pressing Shift plus F10. We see it prints out hello world for us on the terminal. Okay, um, what we just saw here, hello world, is a string. A string is, it's a programming term that means like a series of characters. A string is a programming term that means a series of characters. A series of characters, and it's mostly between quotes, quotation marks, either single quotes or double quotes. The choice is actually yours, but always try to be consistent. And then like one rule is you can't start with a double quote and then end with a single quote, or you can't do the vice versa. So like always take note. If you are starting with a single quote, make sure you are ending with a single quote, and don't mix things up. But like for consistency's sake, in Python, when you are programming, or when you are writing code, just take like choose one style and just stick to it. Maybe you want to choose with single quotes, just stick to single quotes in your code. This will actually make your code consistent, and like it will make it uniform everywhere. Okay, so we looked at strings, and we saw that hello world is a string, a series of characters between quotation marks, either double quotes or single quotes. And like strings can be multiplied by integers, and we all know what integers are. That's any number from a zero part. I'm not really sure, but let's see. Let me just test this out. So let's say print. Okay, so zero is also an integer. Um, if you don't know, if you are confused at this stage, don't worry. Very soon we're looking at the type function, the inbuilt type function of Python. But for now, don't really bother yourself about that. Okay, so strings can be multiplied by integers. So any number from zero to, you know, infinity. Once any integer from zero to infinity. Let me say it that way. So you can let's say I want to print. Uh, Earlier on we saw print hello world, right? So hello world. So here I can multiply this string by an integer, and then um, it will print the string. The print statement would actually print the string, but the number of times I'm multiplying it by. So maybe if I'm multiplying by 4, it will print it 4 times. So if I run this, we actually see that hello world gets printed 4 times on our screen. Okay, so that's just how you can uh, multiply strings. So with this maybe with this you can actually get to draw patterns, or just make things quicker for you. So maybe like, let's say I want to print maybe 200 asterisks. So all I have to do is just put it um, in between quotation marks. That's a string, and then the multiplication operator for the operator for multiplication in Python is asterisk. So asterisk and then 200 by the number of times I want to print it. So when I do this and then I hit enter, we see that it actually prints it 200 times on the screen here for us, and we can see it goes on and on and on till the end. Okay, so with this we can print patterns on the screen. So let me just say we want to print maybe the letter F. So first of all, let me make here 8 the top. the top. So this will serve as the top of our f. So the top will contain eight characters. Let me copy this, highlight this, and copy it by pressing Ctrl C. You can also right click on it to copy. Just Ctrl C. Actually, copying and pasting is very good. With that way, you get to work faster. So let me paste this. I want the middle to contain just let's say 1. So I don't even need the multiplication. So let me just. I also need maybe here 2 to be 1. So I don't actually need this multiplication too. And then somewhere in the middle, I need it to be like maybe like let's say 5. Okay, and then we can actually come here, and then let's copy this again, and then let's paste it down here. Okay, so when we run this, we see that we get an F on the screen down here. We can see that we've been able to print the pattern F on our screen. You can also try this on PyDroid. It will work perfectly fine. It doesn't matter what device you are on. You can also try it on your Android smartphone on PyDroid, and then it will work perfectly fine. And then I can also make this an E. So let's say if I copy the first statement, okay, and then I bring it down here, I bring it to the last line, and then I paste it there. When I rerun this, you see that now we have an E instead. So we have a E with the top having 8 characters, and then in between, from there to the middle, we have one character each, and then somewhere in the middle we have 5 characters, and then it goes on and on. Okay, so that's actually how you can do this, and it's quite easy. You would actually get used to it very, very fast. Now, sometimes you would like to take the value for a variable from the user via the keyboard. We'll be looking at variables later, but Python provides a built-in function called input that gets input from the keyboard. When this function is called, the program stops and waits for the user to type something. When the user presses enter, the program resumes, and the input returns what the user typed as a string. So there's an inbuilt function in Python called input. We already saw print. We already saw print. Print is also an inbuilt function. There's another one called input. So just say input, and then open parentheses, open and close parentheses. Okay. So when you run this, and then we check down below here in our terminal, we say that the program doesn't terminate. It doesn't terminate because the input is waiting for us to type in something. Okay, so let's say I just type in anything and I press enter, and we see that the process has finished with exit code 0. That means it has terminated successfully. Okay, so that's basically what the input statement does, or the input function does. Okay, but before getting input from the user, it is a good idea to print a prompt telling the user what to input. You can pass a string to input to be displayed to the user before pausing for input. So with this one, we saw that if you were a user, and then you are running the software, and then you say that it doesn't ask you for anything, you get confused. You don't know. You don't actually know what the program is asking for. But like we can make our code look nice, or like we can try to prevent this confusion of users by adding a prompt. So maybe I want to ask the user, what is your name? So I'll pass a string to the input statement, or to the input function, and then I say, what is your name? We already saw what strings are, so just what is your name, and then you can put a space in after that. You see why very, very soon. So you just, when you do this and then you run this, when you run it this time, okay, just stop and run. So when you run it this time, you see that the program is asking us, what is your name? So now you know the kind of value that the program is expecting you to put inside. You know what the program wants you to do. So now let's say you type your name Assad, and then when you press enter, it continues executing to the end. Okay, but like this isn't really good practice. You can't just ask the user for his name and then you do nothing with it. So in order to do something with it later, maybe later on in your program. Let's say you can actually store this value. The value you are getting from the user is going to be a string. So you can actually store this value in in a variable. So maybe I have a variable called name. We'll be looking at variables later, so don't actually worry yourself on that. But I guess yes, I have a variable called name. Okay, I can create a variable called name, and I do that by saying name is equal to input, and then our prompt, whatever we are going to as a user. So what this does is we are taking the value from the user, whatever the user is going to type, and then press enter. Whatever input we are getting from the user, we are taking that value, and then we are saving it in the name variable. And then with this, we can actually come and then use this name variable anywhere in our code. Okay, so let's say I come down here and I say print name. Okay, so this time around, when I run this code, I get something, and I say Assad. I type my name, and I say Assad, and I press enter. You see that my name gets printed on the screen for I say Assad. Okay, now let's see how can we make this, maybe like how can we print a beautiful message on the screen for our user. Maybe like we want to ask the user for his name, and then like probably you say hello, whatever name the user gave you. And so in order to do that, we can achieve that by actually concatenating strings. And like string concatenation is just about adding two or more strings together. You can actually concatenate as many strings as you want. So concatenation of strings. Let's say you have a string, maybe let's say I have the string, sorry, I have the string hello. I can actually concatenate that by saying hello plus hello, and then plus world, hello plus world. Sorry. Okay, so what this will do is this is going to concatenate these two strings. So let me copy this and put it in the print statement so that we actually see what we are talking about here. Control plus X. Let me cut it and then put it in the print statement. So let me paste it back. Okay, so when we print this, this shows that we are concatenating these two strings. We are adding them together. Okay, so when I run this, okay, we still have to do this. So let's just do this so that we can proceed. We see that we get hello world down here, just below Assad. Okay, right. So that's how to do things in Python. You can concatenate two strings. So in order to be able to print a very nice message for our user, maybe we take the user's name, and then we say welcome, then the user's name. So first of all, we start by saying by putting a string, then maybe you can say welcome, and then we give a space because we want some space between the two words, and then we say plus, and then name, our variable. It's also a string. Name is a string because the input function is going to return a string of whatever the user is going to type from the keyboard. So it's going to be a string. So that means you can concatenate it directly. So welcome plus name, and then when we run this, and then the program will ask for our name. Then we say Assad, and then we see that the program welcomes us by saying welcome Assad. Okay, that's beautiful. So like this is basically how you can do things and get to understand things. And like there's really something to take note of here. The way Python code gets executed. Well, Python code gets executed from top to bottom. From the first line, then it keeps on executing down to the last line. So from line one, it will execute down to the end of our code. Okay, so that's how code gets executed. So that's why when we run this, the first thing we get is this prompt, because that's what is on the first line. Okay, all right. So now let's look at values and variables. A value is one of the basic things a program works with, like a letter or a number. Examples of values include 1, 2, and hello world that we saw earlier on, or maybe Assad that or the name of the user that we were getting from our input function. Okay, the above values belong to different value types, which we'll be looking at very soon. Okay, so 1 and 2 are integers, and hello world is a string. We already talked about strings. We talked about how to multiply them by integers, and we also talked about how to concatenate them, which is adding one string to another string. Okay, so a variable is a name that refers to a value. Okay, and an assignment statement creates new variables and then gives them values. So for example, x is equal to 17 is an assignment statement. So x is a variable name, or x is a variable and 17 is a value. So what we are trying to say here is that x represents 17. So anywhere in our code that, so what we are trying to tell the Python interpreter is anywhere in our code that we see x, let's replace that by 17. Okay, so we are telling the Python interpreter anywhere in the code when you say x is equal to 70, then from there onwards we are telling the interpreter anywhere in this code where you see x, replace it with 17 because that's the value x is carrying. And then another example is also name is equal to Assad. Okay, you don't just name your variables anywhere. There are rules governing that, and there are two rules. Variable names can contain only letters, numbers, and underscores. So maybe you can use letters or numbers or probably underscores to name your variables and nothing else. You can't use comma, you can't use spaces, you can't use anything. You can't hyphens, no, forward slash, no, or backward slash, no. Just underscores or maybe numbers and letters. And a variable name cannot contain spaces. I already spoke about that. And variable names cannot start with a number. So variable names cannot start with a number. It can either start with a letter or an underscore. Mostly what underscores are used for is probably like it's used to separate maybe your variable name, it contains two words, maybe first name. Let's say first name. So let's say first name here. Let's go to Python. And then when we say first name, okay. So let me simply clear this. So when I want to name my variable first name. I want to take the first name of the user. Okay. So first name. If I just type it like this, this is not readable. This is actually not readable. Like it's even if you can see Python has underlined this with a grid line. That that actually means a grammatical error. Anytime you see a green underline, that means maybe a spelling mistake or something. Now, so this doesn't look clear. Like it doesn't look clear enough. Maybe if you are writing it, you might know you might see it clearly, but like maybe like after a month or so, and then you come to take this, you might actually overlook certain things like this. So in order to make this very clear for us, we can add an underscore. So when you look at this, you see that first is separated from name. Okay. Another way you can possibly do this is to use camel case. And camel case, like with camel case, every after except from the first letter, the beginning of every word is capitalized. Okay. The beginning of every word is capitalized. So maybe if I'm adding another word here, maybe let me say first name, and then I'm saying last. I have to capitalize last, like the first letter, the L. So this is camel case. So you can either use underscores or maybe use a camel case to actually name your variables. The choice is yours, whatever you choose to do. But just make sure that it goes in line with Python, and make sure that you stay consistent, and make sure that whatever you are doing is standard. Okay, we also saw that variable names cannot start with a number. So one name isn't a valid variable name. When you do that, you get an error in Python. And like variable names are also case sensitive. Variable names are case sensitive. So temp with a lowercase t and temp with an uppercase t are two different variables. So take note of that. This might actually confuse you very soon, or when you actually start typing plenty code. It helps make your program more understandable if you choose names that are descriptive, but not so long that they clutter up your program. So when choosing variable names, you have to choose names that are descriptive, but make sure that they are not very very long. Okay, so just choose a name that is descriptive. If you are taking a name, put choose a variable name. Don't probably say X. When someone is looking at your code and the person see X, the person wouldn't know what value X is keeping. But when you say name, once the person sees the variable name, the person will know that this variable is contains the value of or like a name value, or maybe the name of someone, or the name of something. So a good variable name describes the data it contains. So take note of that. When you're naming your variables, make sure that as short as possible, it can describe the value it is referencing, or the value it contains. And just in case you have more than one, you are going to use maybe two or more words, two or three words. You can either separate them by underscores, or you capitalize the first letter of each word. That's after the first word. So these are just some examples of valid variable names and some invalid variable names. So we have balance is a valid variable name, and then current hyphen balance is an invalid variable name because hyphens are not allowed. It is against the rules to use hyphen or hyphens to name your variables. And we see current balance. This is the camel case we are talking about here, and then also here to we are also seeing current balance to with an underscore. So the choice is yours. Just choose one style and make sure that you stick to it. Okay, to make your code look consistent and make it look neat. Okay, so we also saw that numbers, variable names cannot start with numbers. So for account isn't a valid variable name because it cannot begin with a number. Okay, so all right. Now when you are naming your variables, there's actually something that you have to take note of. Python reserves 35 keywords. Python reserves 35 keywords. That means that you can't use, or you are not supposed to use this 35, like any of these, to name your variables. Okay, so maybe n, you can't pick n. Maybe you want to name your variable class. You are advised not to do that, because like if you do this, you might actually run into errors, or maybe you'll be overwriting some inbuilt functions. So it's advisable not to do that. Anything that belongs here, make sure that you don't use it to name your variables. It's very very advisable. Sometimes you might use it, and once you don't use you don't go forward, and maybe let's say you want to use this class. So maybe you might use it to name your variable, but so far as you don't try to create a class in Python after already using it to create your variable, well, you can it might work, but it's not advisable. Just take a very look at these. I'll be sending you the slides very soon, so just take a very look at them, and then and learn to avoid them. Okay, so now let's look at statements and expressions. A statement is a unit of code that the Python interpreter can execute. For example, print hello world, and we already saw that. We already saw examples of statements earlier on. So a statement gets executed. Okay, and an expression is a combination of values, variables, and operators. And we are saying here a value all by itself is considered an expression, and so is a variable. So 17 plus 3 is an expression. Okay, when you type this, when you write this in the interactive mode, you don't get any output. X is equal to 29. You don't get any output. It's an expression. But statements, sometimes you get output for that. Like it an expression is something, whilst a statement does something. So an expression is something while a statement does something. For example, 2 times 2 is 4, and we saw earlier on here 17 plus 3, that's 20. X is equal to 9. That's an example of an expression. Whereas print 2 times 2 will print 4 on your screen. So print actually does something by printing whatever you are passing to it on your screen. The two behave quite similarly, so the difference between them might not be all that clear. So please take note. Now, as your programs get bigger and more complicated, they get more difficult to read. Formal languages are dense, and it is often difficult to look at a piece of code and figure out what it is doing or why. Trust me, when you start having like 1,000 lines of code, sometimes it gets confusing. You don't know what is happening somewhere, and then it can confuse you. For this reason, it is a good idea to add notes to your programs to explain in natural language what the program is doing. These notes are called comments, and in Python they start with the hash symbol. So an example is below here. We can see that we have a comment starting with the hash, compute the percentage of the hour that has elapsed. Okay, so and under it we have the Python code we want to run here. So percentage is equal to minute, and then parenthesis is equal to parenthesis in parenthesis minute times 100, the close, and then over 60. So we are actually commenting what this is, what this piece of code here is going to be doing. So it's more or less like we are explaining what is going to be done. Okay, so let's try that. uh, let's try that in Python. Let's see some examples of maybe code, of comments, sorry. So maybe to write a comment, just make sure that uh, you begin it with a hash, and then whatever comment you want to put there. So maybe I want to say this is just an example of a comment, of comments. Okay, so this is a comment, and we get to see that when we run this, comments are ignored. When a program is running, it doesn't run with the comments. It just ignores them, and then just runs the code for you. Okay, so this is a comment. There's also another type of comment which is inline comment. So with the inline comment, like that one, is in line with our code. So maybe here I'm creating a variable called first, and I'm saying first is equal to assad. So maybe to create an inline comment, just after assad, I'll leave a space, and then I'll start um, with the hash, and then as already said, comments begin with hash. So that means that anywhere you see a hash and whatever follows on that line, is a comment. Okay, so maybe I want to say here first name. So this is a comment, and when I run this program, the interpreter will ignore the comments and then just run my code for me. There's also another one. So we've looked at inline comments too. We also have multi-line comments, and the way you can write multi-line comments. The name the name is self-explanatory. That means it runs across multiple lines. Okay, so in order to be able to do this, you need to open and close three what do you call it, quotation marks. Okay, so as you can see here, I have 1 2 3 opened and closed. Okay, so in between that, then you can then type your comments. So maybe I can say example, and then press enter, and then I say example, and I come again multi-line. I just want this to spread to span across multiple lines. Okay, so an example of, I know, you get the idea. So that's how you can print, or sorry, that's how you can create multi-line comments in Python. And when the Python code is being executed, the interpreter will just ignore the comments. Okay, so everything from the hash, it gets ignored. Okay, so let's make progress. Now, Python and enhancement proposals. I really I will encourage you to just Google this and then like just go through it yourself and like get to understand what it is. Like these these are maybe like guidelines on how you should present your code. Like how you should write it so that it be standard. Like and there are many of them. Okay, but it talks about how to structure your code, but just you can actually take a look at it in your free time. Just Google Python enhancement proposals, and then if you want to look at Pep 8 specifically, so just Google Python enhancement proposal 8, and you get to read the guidelines, and then you get to know how to maybe like write your code in a standard format so that people can actually get to see it and then like get to understand what you are doing or whatever you are trying to do on your code. Okay. Earlier on we looked at code execution flow, or how Python runs our scripts. So we said that it runs it from top to bottom. Okay. And we also have order of operations. We also have order of operations and the PEMDAS. The PEMDAS, what it stands for is parenthesis, exponentiation, multiplication, division, addition, and subtraction. So what this means is parenthesis in Python has a higher precedence than exponentiation, and then that also has a higher precedence than multiplication and division. Multiplication and division actually have the same order of precedence, and so does addition and subtraction. So if I were to probably give a quick example here, let's say uh, let me create a variable. Let's say variable x, and then just something here. Let's say 3 plus 6. Sorry, 6 minus 7 times okay times then open parenthesis, open and close parenthesis, then maybe anything. So maybe like let's say 8 divided by 2. Okay, 8 divided by 2. All right. Okay, so 8 divided by 2, and then I can also say what else? There's addition, right? Let me say plus. So I just want to demonstrate exponentiation. Okay, so just 2, and how the operator for exponentiation is just 2 asterisks. Okay, so 2 asterisks, that means 2 to the power maybe 3. So 2 raised to the power 3, that's 2, then 2 asterisks, then 3, that means 2 power 3. Okay, so now if I'm going to print x, if I what do you think if I print x, our value will be? What do you think the value of x will be? Actually, we just talked about naming our variables, and we talked about choosing good variable names, and as you can see, the variable name I'm using here, x, is doesn't actually explain. It's not a very good variable name. So like let's actually change this. Let's say solution. Okay, so let's say solution. Okay, so solution. Okay, so let's actually change this one to solution. Okay, so let's say solution. Okay, all right. So this, okay, I don't know, but like I think this is a good variable name for whatever value we are getting from this. So what do you think when we run this we are going to get? So let's see. When we run this, we get minus 11.0, and we are getting a point 0 because our division actually when you divide, you get floats. Okay, you get floats, and then that's why we are getting that. But like let's see how did the Python interpreter arrive by this, and we have to use the order of precedence, the PEMDAS, and the first thing there is a parenthesis. So that means first of all, the Python interpreter is going to start in our parentheses. Okay, so in our parentheses is 8 divided by 2. So 8 divided by 2 is 4. Okay, so we get our 4 there. The next thing there is multiplication. Sorry, is exponentiation. So that means 2 power 3. Okay, and 2 power 3 is 8. Okay, okay, so we have 4 here, and we have 4 here, and we have 8 here. The next thing is multiplication. So that means we get to multiply this 4 by this 7, by minus 7. Okay, and then it just continues that way. And then to addition and subtraction, and then you arrive at the value 11. So that's the order of precedence or order of operations in Python. Parentheses first, exponentiation next, multiplication and division next, and then addition and subtraction next. Let's also take a look at the Zen of Python. Well, personally for me, I see the Zen of Python to be like a set of wise words to every Python programmer. You know, like it's very very good. You go through this, and like how do we get this? So just in PyCharm, or if you are on PyDroid, okay, let's just see this for now. So in PyCharm, just type import, okay, type import and this import space this, and then when you run this, shift plus F10, or by pressing the run button right here, when you run it, you see the Zen of Python. Okay, let me increase this. Let me maximize this. Okay, so we can see that we get some a very nice title, the Zen of Python by Tim Peters. Okay, so these are just a couple of white words. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. So what this is trying to tell you, a beautiful Python code is better than an ugly one, and an explicit Python code is better than an implicit one. Simple is better than complex, and complex is better than complicated. So it's good. It's good. You just go through this in your spare time. Okay. So let's see. Let's try to demonstrate this on PyDroid. Okay. Sorry. So let's try to demonstrate this on PyDroid. So on PyDroid, it's just the same thing. You just have to do the same thing. So let's clear the string statement, and then import this. Okay, import space this, and to run this, just press on the yellow run button here, and then the Zen of Python gets open for us in the terminal. We can see the Zen of Python by Tim Peters, and then whatever we had earlier on in PyCharm here too, on our Android smartphone. PyDroid is actually a very very great tool. You can program in Python anywhere. Okay, so it comes in handy sometimes. Okay, what could possibly go wrong? We've looked at you printing things, or probably like taking input from the user, but like when you are doing this, you might run into errors. Okay, or even if you don't, in the future you are bound to run into errors as a programmer. As you write code, you make errors. So what could probably go wrong? Let's look at the type of errors that you might run into. Okay, so we have what we call the syntax errors. These are the first errors you will make, and the easiest to fix. A syntax error means that you have violated the grammar rules of Python. You have violated the syntax. Python does its best to point right at the line and character where it noticed it was confused. The only tricky bit of syntax errors is that sometimes the mistake that needs fixing is actually earlier in the program than where Python noticed it was confused. So the line and character that Python indicates in the syntax error may just be a starting point for your investigation. But like most of the times, that's actually where the error occurred. So let's let's try to demonstrate this on PyCharm. So we can see an example here. Instead of print, we are saying print hello world instead of print hello world. So uh, when we come here and we try to do that same thing here. So on say print, okay, print plint instead of print, and then I say hello world. Okay, when I do this, immediately you see PyCharm will underline this. It underlines it because it doesn't know what it is. And when you hover when you hover your cursor on it, you see that unresolved reference print. Okay, so let's say you don't see this area, this one in PyCharm, or probably you're not even in PyCharm and you don't get one, and then you run this. When you run this, Python is going to raise an error. So you see traceback, most recent call, and then it gives us the file and the line where the error occurred. Okay, the line where the error occurred, and we can see a name error, name plant is not defined. Okay, so th- this actually makes them very very easy to find because Python actually directs you to where they are. So in line 1, then you on PyCharm you can see your line numbers just to the left, okay, of around here, and then you can just follow there, and then you fix those errors. The next type of error you could probably run to into is logical errors or logic errors. A logic error is when your program has good syntax, okay, it follows the rules of the grammatical rules of Python, but there's a mistake in the order of the statements, or perhaps a mistake in how the statements relate to one another. A good example of a logic error might be: take a drink from your water bottle, put it in your backpack, walk to the library, and then put the top back on the bottle. Well, when you do this before you get to the library, um, whatever is inside your backpack is going to get wet. So logically, you don't do that. So that's a logical error. What you do is, after you take a drink from your water bottle, you put the top back on the bottle, but you don't just put the bottle directly into your backpack like that. You need to close it. Put the top back on the bottle and close it. Okay, logically, this hasn't been arranged very well. So probably very soon, or maybe as you progress further and you get to type longer code, you'd actually run into these type of errors. Okay. Um, Another type of error you could probably run into is semantic errors. A semantic error is when your description of the steps to take is syntactically perfect and in the right order, okay, but there is simply a mistake in the program. The program is perfectly correct, but it does not do what you intended for it to do. Okay, for example, let's say you were giving your friend directions to a restaurant, and you said, when you reach the intersection with a gas station, turn left and go 1 mile. The restaurant is the red building on your left. Okay, let's say you say this, and your friend follows your instructions to the letter, word for word. Okay, but he or she ends up somewhere else. Okay, so although your friend follows your instructions correctly, he ends up somewhere else. This would be an example of a semantic error. Maybe instead of blue building, you said red building. So your friend actually searches for a red building instead of a blue one, and he ends up somewhere else. So an example is if you want to say print hello world, but instead you say print hello world. So semantically this is wrong, but syntactically it is correct. Logically it might be correct, but semantically it is wrong. So these are some of the errors that you might have run into, or you may be running into in the future. And very soon we'll be looking at debugging, and what debugging actually seeks to talk about is like finding errors in your program or in your code and then fixing them. Okay, either using debugging tools by using a debugger. Okay, um, uh, an error in your code is called a bug. An error is called a bug. So debugging simply means finding those bugs and then fixing them. Okay, so we have come to the end of today's lectures, and it was great. It was great. Next, for the next lecture, what we'll be looking at, we'll be looking at data types and value types. That will be for the next lecture, probably tomorrow. We're looking at data types and value types. We already looked a bit. We already looked at value types earlier on where we talked about integers and strings. Okay, so string is one value type or one data type, and integers is also one data type. So in the next lecture, we'll be looking at that in depth. We will go deep into that, and then we try to get to understand what the various data types mean, or what the various data types are, and what operations can be performed on them, and what operations cannot be performed on them, and what you can do with the various data types, and how to actually convert from one data type to the other. So I'll see you guys in the next lecture. Thank you.